Hello. In this video, I'm going to show you guys how to find or derive the equation finding the volume value for a certain graph revolving around the x-axis. So here we have an arbitrary function y equal to f of x, and we revolve this function around the x-axis, and well, one may ask, what is the volume that we may generate? So now we can let's have a look at what happened at each very small increment as we always go along this graph. So let's start at some arbitrary values between a and b. That's the value of x between a and b. Some value x of I. So that value x of I, there's a corresponding value I sub y, y sub I, because this given equation is assumed to have is first derivative continuous, and therefore the limits exist throughout the endpoints, between the endpoints. Okay, so there's a point, there's corresponding values that we have here. So now let's have a look at this increments. So at this value, we generate some increment x going horizontally, and we have the sort of like the radius, you can think of it like that, and revolving around the x-axis. So we have a radius revolving around an x-axis that gives us a circle, and when that circle is being generated or being operated horizontally, right, sort of like shifting, casting out a certain surface horizontally, we would have a circular cylinder. So we would have something that look like this, a circular cylinder, right, and it has some radius r and some height, right? Okay, so here height here is d of x, right? Or I'm sorry, some delta x, and r here is just the y, the corresponding y value that we have. Okay, okay. So let's have a look at this at the volume of this cylinder, closed cylinder. Okay, so we know the equation for the cylinder is that is equal to the area of the surface, the cross surface, right, times the height. Okay, so therefore to a certain a sub I, meaning the circular cylinder, right, circular cylinder. Okay, this a sub I is equal to, well, you know that the areas of the circle is pi times r squared. R is just a, right? Just y sub I squared times the height, which is delta x, some delta xi. Okay, all right. That's corresponding to a very small increments at we have delta x small enough. We will generate a circular cylinder. Okay, or you can think of it just a piece of a loaf of bread, and you slice each piece like that, and you would have a very flat piece of bread or slice of bread, but it still has a certain thickness, and that thickness is just the delta x, and we calculate the volume of it. So that is the areas of the cross area times the height. Okay, so now we calculate the total area, A total, which means that the sum of all these circular cylinders add up. What does it give us, right? So that would be equal or approximately sigma some I, and that I equals to some n, okay, pi y sub I squared times dx sub I, okay? So this still remains an estimation. If we want something that is definite, and we want to have something that is finite and makes sense, what I mean by makes sense is it exists, right? Some values that exist. You got to put the limit to it. A sense that this thing is differentiable, is continuous, Therefore, its polynomial is continuous as well, so the limit has exist. So therefore, you have at equal to the limit. Crap. Now it's back. I'm gonna cut that out.
You go on Red Bull? It'll help.
Hey, Ian,
So
come and say. What?
Why? No, I think that's your stuff.
Stop!
Okay, sorry. Go.
So a total equal to the limit at delta x sub I go to 0, and you still have the sum I go to some infinity, right? Pi y sub I squared some delta x sub I. Okay, so this is the formalization of how do we have the integral, starting to have an integral. Okay, so now we have this form is equivalent in writing the integral. X go from a to b because we want to evaluate the volume as this function y equal to fx go from a to b, right? X go to a to x go to b. Okay, pi y here is y of x, right? Squared. Time delta x, but since delta x equals to 0, we can call it dx. Okay, so there you have it. This is the derivation of the equation of how do we. I'm sorry, this is not the areas. This is the volume. The volume. Okay. So this is the volume. The volume total is equal to the sum of the very little volumes. The volumes are the little circular cylinders that we derive from the increments we take. So that gives us the integral. Okay. So this is same thing as we derive the equation for the surface area of a certain graph revolving around a certain axis. So this is for when we have the function revolving around the x-axis. What happened when the function revolving around the y-axis? So that when it happens, it's the same derivation, but we have to somewhat change it into a different dependent and independent variables, right? So instead of going from a to b, it goes to c to d, right? For x now it's for y because it's surrounding the y-axis. So from c to b, pi, and here y in terms of x now turns into x in terms of y, and that is square and dy. Okay, so this is the equation for when you want to generate a solid around the y-axis, and here is for when we generate a solid around the x-axis. Thank you very much.